So the first one we're going to do is take a look at surface tension. So this is pepper, okay? So I'm going to sprinkle the pepper on the surface of our water, okay? And as you can see, if I kind of move it around, it's kind of floating on the top. It just sits there, all right? So the reason it's floating, pepper is heavier than water, but it will float on the top because of surface tension, okay? So if we, you know, move it around a little bit, it'll swirl around on the surface. This isn't very deep, okay? But if I take a beaker of soapy water and a Q-tip that I've dipped in it, I can put it down in the center. Hopefully you can see this. And what'll happen is it disrupts the surface tension. So did you see that? The second I put it down, all of the pepper moved from this being all over and it spread out to the sides. Right, so we have a paper clip. Paper clips are made of metal, right? So they don't normally float. There we go. Being held on the surface by surface tension. So we've got coconut oil here, water here. Okay, so I went to find ice cubes and we don't have ice cubes apparently, but these are some chunks of ice from outside. So you can see that when I throw them in, they're melting right away, but they stay right here at the top, right? Can everybody see that that's where they are? Whereas if I take a chunk of coconut oil and put it into my tube, the coconut oil sinks. So for most solids, most substances, the solid is more dense, which means it would sink. But for water, you can kind of see a little bit at the top here, it floats. Okay, and that's because solid water is less dense than liquid water, which is unusual. It goes down. I don't know if you can see that in the thing, but it almost looks like there's like a little bubble on the top. And that's where the water is curving up on the sides and down in the middle. So my best to have you see that. There we go. Okay, not all substances do that. Some, this one is mercury. I don't know how well you can see it, right? It actually curves the other way. So you can kind of see like a little bit of a bubble on top of this one. Maybe. I can walk around the room and show it to you too. And that's because mercury likes to interact with itself more than it wants to interact with the glass, whereas water is the other way around. It would rather interact with the glass and not itself as much, okay? Which is why it like curves up the sides, okay? The curving up the sides, sticking to the glass, that is adhesion. So if you think of an adhesive, what's an adhesive do? It sticks to something else, right? A glue can let you stick one piece of paper to a different piece of paper or whatever art supply you're using, right? Whereas the forces that hold it together are cohesive. But what you'll see will happen is when we put this in, nothing happens. I need my glass ones, but I can't find them. All right, so normally this is, but what normally happens is because water interacts really well with glass, this is plastic, so it doesn't work as well. Because the water interacts really well with glass, the water actually gets kind of sucked up into the glass tube.